Welcome to Edugrow. edugrow.wordpress.com. Please like, comment, and share our videos. Subscribe and press bell icon for new video notification.
Structure of matter. Introduction. States of matter. You have already read in the previous class that anything which occupies space and has some mass is called matter. You also know that matter may exist as solid, liquid, or gas. These three different forms of matter are called states of matter. Matter can exist in any of the three forms, solid, liquid, or gas. These three forms are called physical states or phase of matter. Properties of states of matter. Properties of solids. They are rigid. They have a definite shape and size. They cannot move or flow. They cannot be compressed appreciably. The molecules in solids are closely packed and have maximum attraction. They have the least intermolecular space. Solids have definite shape. Solids have definite shape and volume. Take a piece of stone and place it in vessels of different shapes as shown. We find that the stone does not change its shape. Its shape remains the same in all the three vessels. Therefore, a solid has a definite shape. Now, fill all the vessels with water up to the brim as shown. Place the stone in each of the vessels one by one and measure the volume of water that overflows in each case. The volume of water overflowing in each case is found to be the same. Therefore, we can say that the volume of the stone or a solid remains unchanged. Properties of liquids. Water, oil, milk, kerosene, petrol, and diesel are examples of liquids. They exhibit following properties. They are not rigid. They have a definite volume. They do not have definite shape of their own. They take the shape of the container. They flow from a higher to a lower level. The forces of attraction between the molecules are weak. The intermolecular spaces are more than in solids. To prove that liquids have definite volume but do not have definite shape. Liquids have definite volume but do not have definite shape. Pour 100 ml of milk into three different containers in turn as shown in the figure. Although the volume of milk in each container remains the same, but it takes the shape of the container. Properties of gases. Hydrogen, oxygen, carbon dioxide, nitrogen, helium, argon, ammonia are examples of gases. They exhibit the following properties. They are not rigid. They have neither a definite shape nor a definite volume. They can flow easily in all directions. The molecules in gases have the least attraction for each other. They have maximum intermolecular spaces. They can be compressed easily. Gases have definite volume nor shape. A gas has neither a definite volume nor a definite shape. Take a bottle of scent and open its lid. Keep it in one corner of the room. What do you notice after some time? In a few minutes, we find that the whole house starts smelling of the scent. Gas, which has leaked from the bottle, has filled the room. Difference between solids, liquids, and gases are given in the table. Arrangement of molecules. Solids. In solids, the molecules are closely packed. They have least amount of intermolecular spaces. The force of attraction between the molecules is very strong and free movement of molecules is not possible. That is why solids are rigid and retain their shape. Liquids. In liquids, the molecules are loosely held. There are large intermolecular spaces in liquids. The force of attraction between the molecules is small and the movement of molecules is possible. That is why liquids are not rigid and have no shape of their own. They take the shape of the container. Gases. In a gas, the molecules are separated from one another by wide spaces. The force of attraction between the molecules is the least, and the molecules have maximum freedom of movement. Hence, a gas has neither a definite shape nor a definite volume. Gases and liquids are called fluids because of their ability to flow. Interchangeability. Matter can be changed from one form to another, as we have already read that ice, which is solid, on heating changes to water, to a liquid, and water, the liquid, on heating changes to steam, a gas. This process can also be reversed. If we cool steam, which is gas, we get water, which is a liquid. If water is kept in a freezer, it changes into ice, which is a solid. The above observations show that a change in state of matter can be brought about by changing the temperature or pressure. Elements. The simplest form of a pure substance which cannot be divided further into any other simple substances is known as an element. It is made up of only one kind of atom. Iron, copper, gold, silver, and lead are a few examples of elements. Compounds. A compound is a pure substance made up of two or more elements chemically combined in a fixed ratio by weight. For example, water is a compound. It is made up of two elements, hydrogen and oxygen, which combine chemically in a fixed ratio of 1:8 by weight. Similarly, common salt is a compound of sodium and chlorine. Some compounds and their constituent elements are listed above. Mixtures. A mixture is made up of two or more elements or compounds when mixed in any ratio physically. Take the example of a mixture of milk and water. You can add any quantity of water to the milk, and the properties of the mixture thus obtained are between water and milk. No new substance is formed. Symbols of elements. In chemistry, symbols are used to represent names of elements. Thus, a symbol is a shortened form of the name of an element. Ancient alchemists used somewhat complicated symbols for elements which are shown. Later on, John Dalton proposed the use of symbols to represent atoms of various elements. Some of the representations made by Dalton are given. Difference between compounds and mixtures are listed in the table. Symbols derived from English name of the elements shown on the table. Symbols derived from Latin names of the elements are shown above. Significance of the symbol of an element. Symbol of an element signifies the name of the element, an atom of the element, and the relative atomic mass of the element. As an example, let us see the significance of the symbol Ca. Symbol Ca represents element calcium. Symbol Ca represents 1 atom of calcium. Symbol Ca represents 40 grams of calcium.